Hello and welcome to the lecture series on 8051 microcontroller. In this lecture, we'll be studying about 8051 timers. So 8051 microcontroller are, say, any microcontroller that you see around in different appliances in home, in industries. Uh, they they definitely require application called the delay application or the counting application. These are two basic requirement or two basic need why uh, engineers use microcontroller in these appliances. Say for example, so the washing machine which are used at home. So you normally set some time. So I'm talking about automatic washing machines. You set some time in the washing machine and you want that the washing should go on for that much amount of time exactly. So that is where timer comes into picture. Similarly, you talk about air conditioners. You want to run the air condition for say certain period of time. You'd set that value in the air conditioning system, and the air conditioner will work for that time. Take the other case. Say there is a bottle manufacturing plant, uh, so that need to pack around 100 bottles in a bag. So for that, they have to keep an account that 100 bottles have been manufactured and passed, and then they are collected into some bag. So here the counting applications come into picture. Another example of counter could be in a parking space, which you normally find in airports or railway stations. Uh, so there is a counter. This is a multi-floor parking space. I've shown it here. So you could see that on the bottom floor there is no parking space, while on second, third, and fourth, although they are filled, but space is left. So basically, they count the cars that are coming into that floor, and they keep a note of that. When it exceeds a predetermined predefined value, say 250 cars can be accommodated on one floor, then it starts displaying this message that the parking space is now full. You can use any other floor. Okay, so let's now come to the 8051 timers. Basically, there are two 16-bit uh, timers or counters. So basically, we can use a timer in timer mode or in a counter mode. Okay, so there are two 16-bit up counters. So what is mean by up counters? I will Okay, let me explain it here itself. So basically, if you are saving some value in a register, say you are using a timer T0 and you are saving some value here, it is a 16-bit register consisting of TL0 and TH1, which we'll talk after some time. Say for example, you have say FF or 10 have been saved. Then up counting means the counting starts to move upward. Okay, counting starts to move upward. So whenever a pulse comes, and the next count will be this plus one, and next pulse come and the count will be this plus one until it reaches the full value of FF. So that is what is mean by up counters. It is not counting down, it is not counting down, it's counting up. Okay, so these timer registers, the two timer registers, T timer 0, normally called T0 or T1, registers. They are 16-bit registers, and basically they are composed of two 8-bit registers, TH0, TL0, and similarly T1 is composed of two 8-bit registers, TH1 and TL1. So we know that we have 8-bit registers in 8051. So two registers have to be combined, and they are used as 16-bit registers. Okay, so now again, to differentiate between a timer and a counter, I've just drawn an analogy here. A counter and a timer. Timer basically operates on a fixed frequency clock pulse. Okay, so it requires fixed frequency clock pulse, and the increment is in after a fixed interval of time. So that is a timer. While a counter, in a counter, frequency is not fixed, but the time for which the counter should operate, that is fixed. Okay, let's move. So to understand that, what exactly I mean by fixed frequency and the variable frequency, we know that 8051 microcontroller takes its input from an oscillator, normally 12 megahertz oscillator, and that is divided by 12, and then that comes to two registers, T1 and T0. So if you remember, we have got two pins, T0 and T1, also in 8051 microcontroller. So these are external pins. So we have external access to T0 and T1 also. So the pulses that will be coming from here, if we are using the timers T0 or T1 in timer mode, then we will be using the internal clock pulse. Okay, so each pulse will be generated here after 12 pulses have crossed there. Similarly for timer 0. While if we intend to use 8051 in a counter mode, then we have to use the external pins, and basically it is an event counter wherein the frequency of the pulses that are coming are not fixed. So it basically counts the number of pulses: 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and similarly T0 can also be used for the same purpose. Okay, so normally 6 registers are associated with programming in timer. So TCON, TMOD, TL0, TL1, basically TH0 and TH1. So TL0 and TH0, they are basically part of T0 register, and similarly these two are part of T1 register. All of them are SFRs, special function registers. The number that needs to be incremented are stored in either T0 or T1, or you have the option to use both of them simultaneously. While TCON and TMOD registers have the special function to perform, we will see shortly. While the addresses where these registers are located in 8051 have been mentioned here. So since they are SFRs, so they are stored in RAM. So these are the memory locations where they are stored. So let's proceed and let's see the TCON register. So it is an 8-bit register. So the lower half, the lower 4 bits are basically dedicated to interrupt operation. So you intend to use timer interrupts, then or the external interrupts, then we need to configure them. Otherwise, we don't use them. The higher 4 bits are for time operation, and let's quickly see them. So TF1 is basically the timer 1 overflow flag. Similarly, TF0 is timer 0 over flag. So what it means that whenever timer 1 or timer 0, it overflows. So it is counting up. So it is counting, say, from 100 to 101, 102, and so on till it reaches FF. Okay, and this happens in mode 1. Okay, we'll be talking about various modes also. So the maximum count that is possible in mode 1 is FFFF. So when FFFF is reached and another pulse come, then the timer 1 or timer 0, it is reset to 0000H, and setting this TF1 or TF0 flag, as the case may be. So TF1 equals to 1, it indicates that overflow has occurred in timer 1. Similarly, TF0, when it equal to 1, it indicates that overflow has occurred in timer 0. And when they are 0, that means the counting is in progress. Okay, so let's look at TR1 and TR0. So they are timer 1 run control bit and timer 0 run control bit. So either they are set by software, or they can also be set by hardware also, if we are using timer as an interrupt mode. So TR1 is equal to 1. So when you make this TR1 bit equal to 1, that will trigger the timer to start counting. Okay, so timer 1 starts counting when this bit is made equal to 1. Similarly, TR0, when it is made equal to 1, then timer 0 starts counting. And when it becomes equal to 0, that means the counting has stopped. Similarly, here also. So when TR1 becomes 0, the counting has stopped. We will talk about these bits when we'll be discussing about the interrupts. Okay, so let's now talk about T-mode register. So very easy. So lower half for timer 0 and upper 4 bits for timer 1. So gate basically enables the timer, so you need to set it to 1 to allow the timer 0, and here equal to 1 for timer 1 to work. Okay, so if gate is 0, then timer or counter, they are not going to work. So this is the gate should be 1. And C/T bar. So C, when this is equals to 1, so we are operating in counter mode, and if it is equal to 0, we are operating in timer mode. Similarly, here the timer 0 can be made a counter timer according to the value of this bit. M1 and M0 are basically the mode selection of the timer. So we have got 4 possible values here. It could be 0 0 or 0 1 1 0 1 1, and correspondingly 4 modes 0 1 2 and 3. And we'll be talking about these modes in another lecture. Right now, let's talk about this timer diagram. So it's important to understand this diagram. It's a control diagram. So this is the oscillator. So clock signals is coming from here. So if you're using it as a timer, then you use this one. And if you are using as a counter, then you have to use the external pin. That this needs to be connected here, either T0 or T1 bit. So TR flag, when it is 1, then only the counting starts. So the counting to start, this needs to be 1. Okay, this needs to be set. So it is 1 only if this is 1 and this is 1. When is this 1? When you the gate flag. So this is the gate flag here. So you have to set it to 1. If this is 1, here it is 0, and